Okay, Precalc AB students, it's Mr. Morse here again, and this is 2.3 Day 3 video notes on the intermediate value theorem, which we can abbreviate as IVT. So this first statement here, you must watch the other IVT video first. If you are watching this one first, please stop, go back and watch the other video, and then when you're done with that one, then come back to this video, all right? That first video is a Khan Academy video, and it explains very well the theory behind IVT. All right. I also encourage you anytime you're struggling on any topics that you could go to Khan Academy and simply search Khan Academy for any topic you wish. So you could look for more videos on IVT. Maybe you search limits or one-sided limits, two-sided limits. Everything that you really can imagine is in there. All right. And the videos are great. All right. So let's go through this example here. All right, so this example says, part A, use IVT to prove there is a real number equal to the cube root of 15. This first step right here, and I'll highlight as I go, is simply rewriting those words into a mathematical equation. And so x equals, so is there some real number x equal to the cube root of 15? Now, this is not really in a good form for us to do this proof, right? So this next step is I really cube both sides. So I cube the x and I cube the cube root of 15. So I get x cubed equals 15. Now I really have an equation in which I would solve. If I solve this second highlighted step, I would get back to the first by cube rooting both sides. All right. And so this gets us in a spot where it makes more sense. All right. And so this next highlighted step, whenever we're solving equations, we usually move everything to one side equal to 0. So I simply subtracted the 15 from both sides, and now I have it equal to 0. And this is really the best form right here. So this is going to be the key, this 0 right here. And so definitely, if you watch the other video, which again, I've said a couple times now, I think you really should, what happens is that I want to prove that x cubed minus 15 equals 0 for some x. To do that, I need to get my conditions in IVT, which sets this 0 in between two other y values, like f of a and f of b, as the theorem states. So now, let me go over to this graph over here. So I'm going to jump over to this graph. And this dot I'm going to put here is not really part of this graph. I'm just trying to explain something. So if on the x-axis I have some ordered pair there, its y value would be 0, and it would be an x-intercept, right? All right, so then if I have a graph that's continuous, I'll get to that here in a second, that crosses the x-axis. Whoa. All right, sorry about that. Happens every once in a while. You've seen it before. All right, so, all right, let's say I have a graph that crosses the x-axis, right? Well, what's happening here is if this y value is 0 and I have some positive value over here, then I would have some negative value over here. If the function is continuous, to get from this negative value through the x-axis to this positive value, I would have to go through 0. So that's really the key to this and why I set this equal to 0. Because we know then if I can create a negative value and a positive value, that the 0 will exist between them as long as the function is continuous. All right, so this next step right here is simply notation. So in my proof down here, you can see I've used f of x, f of 2, and f of 3, and I'll get to that in a second. But f of x has to be defined somewhere to refer to it in my proof. I can't just all of a sudden say f of x is whatever, not having initially defined f of x as my function. So f of x is equal to x cubed minus 15. All right, and then also over here in the graph, I've graphed f of x. All right, so the first part of IVT is you have to determine if your function is continuous. All right, for anyone to use IVT, you have to have a continuous function or it doesn't guarantee the rest of the conditions. All right, so this next step, and now we're getting to the proof. All right, so the proof if I state that f of x is continuous, that's because x cubed minus 15 is a polynomial, and it is indeed continuous. So my very first thing I always start out is saying f of x is continuous. All right, this next step, all right, this right here. I have to guess and check, all right? I need to plug values in, and I'm going to plug values into this step, into x, all right? When I plug in values to x, my goal is to find two x values such that the y values, and I'll explain this more in a minute, here and here, end up being one negative and one positive. And that's because 0 will exist between a negative and a positive, like I showed you over here, all right? As long as the graph crosses the x-axis, all right? And if you do have a negative and you do have a positive on one side, a negative on one side and a positive on the other side of the 0, then it will have to go through 0 to get there, right? So I start out up here, and let's just start plugging in values in which I know I'm going to get a negative when I plug in. Let's start out with 0. When I plug in 0, 0 cubed is 0, minus 15 is negative 15. All right, so then I want to start plugging in larger and larger values for x in integer increments until I get one value that's negative and the next value that's positive. All right, so and the other thing is negative 15 is pretty far away from 0, so let's try to get closer. So instead of 0, let's plug in 1 in for x cubed. 1 cubed is 1, minus 15 is negative 14. All right, getting closer. Let's plug in 2. So 2 cubed is 8, minus 15 is negative 7. All right, getting closer to 0 yet. 3 cubed, I'm just going in order, all right, increasing my integer values. So 3 cubed is 27. 27 minus 15 is 12. So now notice I went from a negative to a positive. So I know those are my two values I want. And so when I plug in 2, I get a negative 7. When I plug in 3, I get a positive 12. So what you want to do is try to find consecutive x values, like 2 and 3, such that their y values, one is a negative and the next one is a positive. So once you do that, and I'll show you the graph over here, and then I'll explain the last step, is once I do that, so this is the graph of f of x, which is x cubed minus 15. So I've already plotted 2, negative 7, and I've plotted 3, 12, which are the values I found right here. And so we've already established that this function is continuous, and of course you can also see it on this graph right here. If I am trying to graph a continuous function from 2, negative 7 to 3, 12, to get from here to this ordered pair here, I'm definitely going to cross the x-axis somehow, all right? And that's the whole idea of this proof. If my y value here is 0, and it's between this negative 7 and this 12, then I know that this 0 has to exist between this 2 and that 3. It has to. This graph will have to cross the x-axis between that 2 and that 3. All right, and so that's what I said in this statement right here, which I'll highlight. So this statement says, since 0 is between negative 7 and 12, there exists an x in the interval 2 to 3 such that f of x equals 0. All right, and so that really concludes this problem. I've really shown by IVT that there is a real number equal to the cube root of 15. All right, all of this stuff has to be written. You do not have to provide the graph. Again, what I like to do is provide algebraic representation, numerical and graphical, anytime we can to connect all three. All right, so let's move on. So, and again, just to make sure that I've said this clearly, you would have to write all of these highlighted steps. All of this has to be in here. It's very common for students to accidentally forget to say f of x is continuous. All right. So really the last part of this is part B, goes pretty quick. Part B is actually finding the real number that exists. So really all you have to do here is take the cubed root of 15 in your calculator. And when you do that, you get 2.466. So let's go back up here just for a second so I can get the graph and the explanation here on the screen. So the value, whoops, the value 2.466 clearly exists between the 2 and the 3. So it clearly exists between the 2 and the 3, and you can see it here as well. It exists between 2 and 3, and if you plug that into x cubed and subtract 15, you will get 0, which is the answer to the cube root of 15. All right. Now I put a note here in the end that says problem 5 and 7 on your worksheet should be done this way using IVT. The directions on the worksheet may not be very specific, but on those two problems, we want you to write them out like this as if they were proofs. All right, that concludes the lesson for today on IVT, or the intermediate value theorem. Have a good day.